PowerPoint here for the directions on how to do this. So if you have to do it again on your own, there'll be the video and the PowerPoint to help you have to do it again if you have to redo this for any reason. Reasons you might have to redo it. Your memory gets cleared is likely the situation that would happen. So if that happens, like, go find the video and the PowerPoint on the class page and you can rewatch it or just look at the PowerPoint, and after you've done it once, it's not too hard to do again. The PowerPoint's pretty good. Okay, so I need everybody to power on their calculator. And you're going to start by pressing the program button. If you're not sure where the program button is, the PowerPoint here has a nice arrow showing you exactly where that program button is. When you press the program button, your screen should look like this. What I need you to do is use your arrows to move over to the New tab and select Create New by pressing Enter. You now have the option to name your program something. So if you look on your keyboard or on your calculator, there's little green letters, A, B, C, D, E, F, G, etc., kind of all scattered throughout. If you press a button with a letter, it'll type that letter here. I'm going to name my program Quad, but you can name yours whatever you want. You can call it Hubert or, yeah, if you want. It's just a name. Julia? So you see where this big red arrow is pointing on the screen? What brand is it? I promise you there's a program button on there somewhere. All right. Next up, once you've entered the name, go ahead and press the Enter button, and the screen should change to look like this. Okay. The first thing that we're going to do is we're going to have our program clear whatever was on the screen before so we can display the information that we need to enter into our calculator. So to find the command that we're looking for, we need to press the program button again. When you do that, it opens up a menu that looks like this. I want you to use the arrows to move over to the I/O menu. And from the I/O menu, we're going to select the Clear Home command. So move your cursor down to the Clear Home command and then press Enter, and it should then put it on the screen. Anybody still working on doing that, other than Julia, who hasn't figured out where the program button is on her calculator yet? Okay, good. So press Enter one more time to move to a new line. And now we're going to press the program button again, move over to the I/O menu, and this time select the prompt command. And press Enter to select it. After the prompt command, we need to type in the letter A. So we're going to press the alpha button and then the button right below it to get the letter A to show up, and then press Enter to move to the next line. Okay. Okay. All right. Once you have prompt A on there, go ahead and repeat that process 2 more times and do prompt B and prompt C. What the prompt command is doing is the calculator is going to ask the user for a value for A, a value for B, and a value for C. So it's going to allow us to enter in the values that we need to use to do the quadratic formula. Did you find it, Julia? Okay. That's a good solution. That's what I do whenever anybody has a calculator problem that I'm not sure what to do with it. Is somebody on YouTube will explain to me what to do with it. Probably. That's probably what they're doing is the same thing that we're doing here, or close enough that it'll do the same thing. All right. So now that we've typed in prompt A, B, and C, make sure you're on a new line. So after you've pressed or typed in prompt C, make sure you press enter 1 more time to move to a new line. And what we're going to do is we're going to type in the quadratic formula. So you should type this in exactly as it appears on my screen. Before you start typing though, pause 1 second. You see this arrow at the end here? The button you need to press to get that arrow is the STO button down here. So that is a subtraction symbol here and a negative symbol there. Yep, the arrow after or right before the D. It's right here up. So you press second and then the X squared button. Madison. Come show me. That's the division symbol, dude.
What?
Just press alpha on that button.
And and the rest.
You have to see where the little A is above it.
Yeah.
So the green letters you'll access by pressing alpha and then that button to get that letter. So notice that there's not a colon at the start of that second line, so don't press enter there. Just keep typing, and your calculator will automatically move you to the next line. So the colons on the side there indicate the start of a new line. This is all one line, though, so don't make sure you're not pressing enter. You just keep typing, and it'll automatically wrap it to the line below, because the calculator needs to know to do all that stuff at once. It's not 2 separate command lines. That's all one command line. Yes? Yeah, there are 2 parentheses there at the end. Yes. The slash is division, dude. I would have hoped that by this point you've used your graphing calculator to divide something. All right. Next step. It's the same thing, except for, notice what's different? Yeah. So remember the quadratic formula has a plus or minus there? There's no plus or minus button on our calculator, so we're just going to do it as 2 lines, one with the plus and then one with the minus. The second one will go much faster though once you've done the first one. Right? Once you've done it once, it should go faster a second time. Well, Lee, it's the same thing you typed before. It just has one symbol different. Julia, how's it going? You making progress? Dude, what? So, just to reiterate, what these last two lines are doing is we're taking the numbers that we input, and for A, B, and C, it's doing the quadratic formula, and then storing that answer into the space for D, and then storing our other answer in the space for E. Okay with that? Anybody still typing? Okay. We're almost done. So we have now, the program will at this point have calculated the answers. What we still need to do, though, is have the calculator display the answers for us so we can see what they are. Because right now they're just locked away in the memory somewhere. We need the calculator to put that answer now on the screen for us. So to do that, we're going to use the output command. So after the arrow E, make sure you've pressed enter to move to a new line. Then you're going to press the program button, move over to the IO tab, and select the output command. And you're going to type in output 6, 1, D. It's right above the 7. What this output command is doing is it's saying on the 6th row, in the first column, we're going to display the answer for D. The comma is above the 7. That is a D there, yes. Yeah. Julio? I can't hear what you're saying right now. Can you either speak up or come and show me? Okay.
I did it. He said to plug it in to see, and I didn't get the same thing that he got, so somewhere I messed up.
How do I get over to the program so I can look at what you typed in? Why is that not coming out? So how do I just type it in like down here? Could have picked a shorter name.
I didn't realize that.
One. Yeah, that's not the right answer. What is this angle thing at the end?
I have no idea.
All right, the last step. You're going to press the program button again. From the CTL menu, scroll all the way down to the bottom to find the stop command. Once you've done that, you can exit out of the program by pressing second and the mode button. Mode, right next to the second button. I wonder if we could do that. It did not delete it. It's still there. I'm not sure what's going on here, Julia. We'll come back and revisit this again. Take a second look through the video and be very careful. There's got to be something in here that's going wrong. I don't see anything wrong with your quadratic formula per se that you've written. I think it might be in some of these commands beforehand that I'm just not familiar with, like what libpub means. Or if all the formatting is correctly or is done correctly. I'm not sure what the angle negative 135 is telling us, and obviously this is, that's not the correct answer. So I'm not positive right now, but I don't see anything obvious wrong with the formula. All right. So everybody got their program completed. Let's check it now to make sure that it's working correctly. So to do that, I'm going to use the assignment from last time to use for my checking. Well, you can use it to check your answers, but I'm not going to accept answers with no work as full credit. We'll talk a little bit more about the expectations for the test when we're getting a little bit closer to the test. Probably 2 class periods from now. All right. So, notice on number 1, I forgot. Oh, that's not what I want you guys to be able to see at all. All right. So for number 1, let's test that out. So this is how we use our program. We're going to press the program button. From the execute tab, we're going to select our program by pressing enter. That'll put it on the main screen for us. We'll press enter again to run the program, and now the calculator is going to prompt us to enter the values. Let's use our calculator to get answer number 1. So what is my value for A?
X squared.
Not x squared. 1. What is our value for B? -9. And what is our value for C? -22. And that spits out and it says my answers are 11 and -2. If you did not get negative or 11 and -2, come talk to me because we have an error somewhere in our program.
So if I work, I can show.
Just as the done.
Okay. So you have an issue with your output. Oh, that does not seem like there's an issue there. I see one issue. I'm missing a parenthesis there. And there. I wonder if that cleans it up. Yep. So. It's this. It needs to be on a separate line. Yeah. Just double check here. Other than that, real quick, that's all. The rest of that seems okay. Here we go. Your battery's going to die, though.
I know. I don't know what my charger is.
No, I think it'll probably store in your long-term memory, but charge your battery. All right. Let's do the same thing here for number 2. You don't even have to press clear. You can just hit the program again. What are we going to put in for A? 4. What are we putting in for B? Nope. Nope. 0. Well, do you see any X's in there? Regular X's. No. So what does the coefficient on the regular X have to be? 0. You probably pressed enter too many times and it didn't take a value for A. So Tom, you just need to press enter all the way through, take the error, and just start it. Restart the program. There's no way. Our program is not sophisticated enough to go back and re-enter a value.
Why isn't it 4x squared?
Well, the A is the coefficient, not the variable.
A is just a number to us.
Yes.
Yeah, I could square because that's
Correct. All right. How about to do number 3? Let's do number 3. What are you going to have to do first before you can do number 3? Good. Ryan, everything's got to go onto the same side. Do you see a x term? Okay. So I'll subtract x squared from both sides. Subtract 3x from both sides. Add 15 to both sides. Is that what you guys got? Got it. It's got to be equal to 0 for us to be able to use the quadratic formula. Yep. All right. Do 8. Nope. Do 8. Not interested in 4. I'm interested in 8. That doesn't matter. The quadratic formula should work for all of them. Nope, there's nothing wrong with the quadratic formula. Well, when we do this, sounds like some of us are getting errors. 4, -3, 10. Okay. Well, let's see what happens if we actually try to do this by hand. Yes. Okay, so that's to here. What's the issue here now? Can you square root a negative number? Okay. So what have we done in the past when we get to a problem that we can't do? No. We don't stop. No, we don't quit. We extend the set of numbers we're working with so that we can now solve this kind of a problem. And you say, wait a minute, that's a bunch of malarkey. And I would say you've done that at least 4 times so far in your math career. So let's go back to elementary school. First thing you learned in math class was counting, right? How did you learn? What numbers did you use for counting? Exactly. Positive whole numbers, right? After you learned how to count, you started adding, right? And if you add 2 positive whole numbers, you just get another positive whole number and there's no problem. After you learn adding, though, what do you do next? Subtracting. When you subtract 2 positive whole numbers, is there an issue? Possibly. What about 3 minus 5? What are you going to get? Negative number. So what did you have to do? You had to add a new set of numbers so that you could do that kind of a problem. You added negative numbers. Before that, they didn't really exist for you. You just had positive whole numbers, right? Okay. And then you did this for a while. A couple grades later, you started to multiply. And there's no issues. But after you do multiplying, what do you start doing? Dividing. And what's the issue with division? You can get decimals and fractions, right? If I do 7 divided by 6, that's not a whole number, right? So what did we do? We added new sets of numbers. We added the rational numbers, things that could be written as fractions. And that was all fine for a while. And then you talked about things like square roots, like this numbers like the square root of 2 that can't be written as a fraction that are still decimals. Those kind of numbers we called irrational numbers. So we added those in so we could start taking square roots of everything. And at this point now, if you take your positive and negative whole numbers, all the things that could be written as a fraction, and all these irrational numbers together, we called those the real numbers, and that's what you've been working with until this point. But now we've run into a little bit of a problem. This is a problem that we'd like to be able to solve that currently doesn't have a solution inside of the real numbers. So we're going to create a new set of numbers in which we can solve this problem. Everybody okay with that idea? All right, so let's describe what this new set of numbers is going to look like. We're going to define a specific thing called the imaginary number, I, which we're going to define as the square root of negative 1. Now, I want to be clear about this name. When we say imaginary number, it doesn't mean that it's like made up any more than any of the other numbers are made up. Because we had referred to that previous set of numbers as the real numbers. This is not a real number. So we used kind of the English language convention of what's the opposite, something that's not real. It's imaginary, although it has nothing to do with like, ooh, it's made up. That all the numbers are the same amount of made up. Okay? So if I is equal to negative, or the square root of negative 1, what can I say I squared is equal to? Negative 1, right? Everybody's okay with that? So I'm going to use this imaginary number along with the real numbers to define a new set of numbers called the complex numbers. So the symbol that we use to represent the complex numbers is this C with a bar. And the complex numbers are the set of numbers that look like A plus BI, where the A's and B's are real numbers, and the I is this square root negative 1. This symbol here means is a member of the set. And this symbol here is the set of real numbers. It looks like a curvy E, yes, is what that symbol looks like. Like that. A giant blown up one. But yeah, it looks like the capital letter E curvy. So let's look at some examples of things and try to make a decision if it's a complex number or not. Sound good to you guys? All right. How about something like 2 plus 3i? Is this a complex number? Definitely is, right? it's easy to see that there's my A part, there's my B part, and there's my I. Everybody can see that? Just as a piece of vocabulary, this part, the A, we call the real part. This part, the BI, we call the imaginary part. Since A is just a real number, and BI, well, it has the imaginary number stuck to it, so it's an imaginary number. Okay? What if I have just 7i? Is that a complex number? Sure it is. Why is it a complex number? Because I can write it as 0 plus 7i. Complex number. Right? Here's my A. Here's my B. And there's my I. Everybody agree with that? Okay. Is this a complex number? Yes. Why? Well, I can write as 6 plus 0i. There's my A. There's my B. There's my I. That's a complex number. What's the takeaway here? Yeah, everything that we have now is a complex number. Sure. Like 3/4, I can just write as 3/4 plus 0i. Because 3/4 is a real number, it can be a value for A, so that's fine. Everybody okay with this idea? Now this is really nice because the complex numbers have captured everything we have before, right? It has all the real numbers in there, but it also has some stuff that we didn't. It has all these numbers that have this imaginary part attached to them also. Before we go on, let's take a moment and just talk about how we manipulate these complex numbers. We should talk about how we add, subtract, and multiply and divide with them, because that's maybe not entirely clear at first glance. Because remember, when you added negative number, or started talking about negative numbers, the way you added negative numbers and subtracted negative numbers was a little different than the way you added positive numbers. The same thing was true when you put in fractions and decimals. The way you added and subtracted, multiplied, and divided fractions and decimals was a little bit different than the way you dealt with just regular whole numbers. So we do need to talk about that. So here we're adding two complex numbers. Everybody can see that? Best case scenario, if you were hoping for how you would want this addition to work, how would you want it to work? What would you want the answer here to be? What method of addition would make the most sense here? How about that? What did we do here to get that? That's what we did. What are we basically doing here? Combining like terms, right? That's what I would hope would be the way that this would work. That's the really kind of expected that, oh, I'll just add the parts that don't have the i's together and add the parts that do have the i's together. Everybody okay with that idea? How would we subtract these two things then? Well, what's another way to think about subtraction? I can think about it as adding a negative, right? And when I have a negative sign out front of a set of parentheses like that, what does it mean that I need to do? It means I distribute that negative inside of the parentheses. And what this has become then is just an addition problem. Yeah, that's probably the easiest way to think about it. Just to turn it back into an addition problem, which was easy to do because we're just combining like terms, right? How far? So let's say I wanted to multiply 3i by 2 minus 5i. How would you hope that this works? I mean, wouldn't you want to just to distribute here? That seems like that would make the most sense. That is indeed how that multiplication needs to work. So 3i times 2 is 6i. 3i times 5i is 15i squared. But remember, what does I squared really equal? Equals negative 1. So negative 15 times negative 1 is really positive 15. And then I'll write the 6i at the end. So that's good, right? That multiplication worked exactly kind of the way we'd hope it would. Or I just need to distribute. What if I had multiplying two fully complex numbers? What would you hope to do here to multiply these? I would hope that we just FOIL, right? This looks like a FOIL situation where I have two parentheses multiplied together, and that's indeed what we should do here. Remember, though, what is I squared? Negative 1. So I have 15 minus 6 times negative 1. That's same as plus 6. So 6 plus 15 is 21. Negative 9i plus 10i is just 1i. So not so bad, right? Different than the way we added regular real numbers, but not, or multiplied regular real numbers, but not so bad, right? Basically, we've just been treating I kind of like a variable and doing the same thing that we would expect, right, Caden? We're going to circle back to that in just 1 second. And if not today, then next time we'll circle back to it. So far, everything has kind of worked nicely, kind of as we'd expect it to. Division, this kind of falls apart a little bit. Division is a little bit more complicated than maybe we would hope. So the way we're going to do this is we're going to think about the division applying to each term. In the case where I have a purely imaginary divisor. All right, we'll finish up talking about this next time. Remind me where we left off, guys.